Yep, we are live.
Hello. So we are going to solve the famous three number sum problem of AlgoExpert. So it is a very famous problem which interest might ask in a lot of different interviews, mostly for full stack or front end or Java, anything.
So
So
this
Nikhil, will you
question is all
elaborate
about
on the question?
a function that takes a non-empty array of distinct integer and integer representing a target 3 sum. So is it like we need to find all the combinations of three numbers that whose sum are equal to the target sum?
Exactly. So we have to find every group of numbers which have the sum equivalent of target sum. So this is the question here. It's like
Okay. So it,
permutation combination. We have to find every combination which contains the
yep,
input numbers and its sums is equals to target sum.
right. So any clue?
Okay, so any clue? So right now I have no clue to how to solve this question, but let's think.
One thing we can do is we can start picking each number, like kind of iteration, and start
Okay,
subtracting from the target sum. So we know like what's the remaining sum is
okay,
should be present. There should be two numbers present in the other remaining. So it's too confusing. So basically we need to minus that number from the target sum, whatever the remaining sum is. Now we need to find two numbers, so that become a small problem where we need to find two numbers whose target sum is that remaining sum, if that makes sense somehow.
okay. So I think the solution you have told me, we have to use this in every input, or I can say every part of that output array. So if we have five arrays which have equivalent of target sum, to find that one value of the target array, we have to use that logic which you have told. Before that, we have to use some method by which we can get multiple, I can say multiple arrays which have those targets and values. So we will use recursion here, and we'll pass a single array to it, and then in that recursion function we write that logic, and we subtract our numbers from a target sum, and we'll find if that value is equivalent to target sum or not. If it is equivalent, then we will return that values abandoned in a array and return to the recursion main function, the first function, and then using with the help of recursion, we can get mm, all the triplets which have the same numbers, which have the same sum, target sum, like all the combination of all the
Yeah.
triplets.
So maybe we can write some kind of pseudocode so that we can remember what we are discussing, so that we can write it further on.
Okay, so for this,
So
we have to,
first thing first, we need a function that can do two numbers sum.
yes, it's not two number sum, it's three number sum.
No, no. So
So
that's we already have a three numbers sum function. But when we are we can say that's like drilling down the problem. So we need to find at least at the bottom, like that is two numbers sum. So maybe need the function that can do a two number sum for us.
we are going to use that two number sum for short, and we are going to return some final array. I'm not,
That will be array of array.
that will be array which have all the triplets combination.
So it's a kind of arrays of arrays.
Yes. And what we have to do, we have to use this function.
Yep.
Let me this function. In that function, we are going to look at. So let's think what we have to pass here. For sure, we have to pass an array, and
We need to
value
pass the target sum. That will
target
not
sum
be
as
the
well.
exact target sum that we are thinking, or will that be a possible
Target
case?
sum is the same for every triplet,
But that's for triplet now. But here we are doing is two sum. That's my question.
but we are passing the I, so we will add that I every time. Like we are iterating in the array, and we are passing the values of that array. So if it is, let's suppose two, we are in the second position, then we will check the two number sum plus that input we have passed from the above function from the array, and if that equals equivalent to target sum.
Okay, let's do
So
it this
by
way.
this we can get three number sum with the help of two number function, because we are passing the I value from the above recursion method.
But
The
this
above
this thing will return in one go. Line number 4 will return on the first iteration. Maybe we need to save it somewhere and then return, because we cannot return there.
yeah.
Yeah, maybe we can store this the output of this function in some kind of array.
Okay, so let me create an array here. Let me say it is an blank array, and in that array we are returning that. Should we use append here?
Yep, we need to use the append. In Python, do we have anything like kind of push or something, add, like kind of add function or something?
We have to append it,
Ah, then it's good. Now we can use append.
and we don't have to make it equals to. We can directly append it. So it will append a two number sum.
And at last we
If
will like return this out.
yes. Um, can you check, Nikhil? Like, can you think if we have to pass only three inputs here?
Hmm. How is it if we pass an array, we pass the index?
We have passed the array to get the other two values, which we are going to use on the two sum, two number sum,
Mm-hmm.
and the I is for the third number. But apart from that, do we need any more inputs?
Maybe, maybe not. Let's try it after some time, like how it goes.
Okay.
Yeah.
Uh, so I'll say we have fixed I for this two number sum. Let's say L would be the left input of that array, and we have to find the first element. So I'll say it would be array of 0.
Or we can do it this in this way. Let's not pass that number of array, like in line number 4 I'm talking about. So the context is we will not pass the number of the array, but we'll pass the index of that array. So I think that will help us to find the position, any like find the value of the index anywhere we want, so that will be much easier to do. So instead of doing for I in array, let's do I in length of array, like you can do in Python range of length of array.
But if we do this, we are passing that index in that two number string,
Yeah,
two number sum, and in two number sum we have to use that index and find the value again
yeah,
while adding it.
yeah, because that will provide us more complexity to use, as because we know the index. Because if we don't know the index, it will be hard for us to iterate over the array and find other number, because we have target sum, we have to subtract, and we need to find another number. So that will not be easy if we just pass the value instead of just index.
Okay, we'll try that.
Because anyway we have the
So,
array, so we can get the values anytime we want it.
mhm, okay, so this I now is the index of that array
Yeah,
which we are passing. So L would be the length of the first element of the array, which is with the zeroth position, I'll use R is for the right element, right rightmost element, and for this we have to do this um, array of what I'm writing. Let me use a different keyboard. Um, Length of array minus one. This would be our right element.
Yep. So now we have the leftmost and the rightmost number. So for that case, because we haven't sorted it, so will that be not any kind of beneficial for us? Because we don't know what the numbers are at left and right. So will that not make any sense if we start using a while loop and adding to the numbers, and if they are greater than target sum, then subtracting the left corner and sorry, the right
Okay,
corner. So
so
we need to
according to
sort
the
it.
question, we have to return the number in ascending order. So to do that, we'll just sort our array in the beginning only.
Yeah.
Now our array is sorted, so we will get the sorted array, and then in that sorted array, we will use the first number and the last number
Mhm.
and the index of the third position to check if that value is equivalent to target sum or not.
So in that case, let's not get the values of array by index, but let's start using indexes itself. Like whatever you have mentioned, these variables L and R. So these will not be
Mhm.
the values of array, but the indexes of array. You got my point. So the reason I'm saying this is when we start using a while loop where we iterate over the leftmost and the rightmost, if their sum is greater than target sum, we need to sum like we need to make the right index
Mhm.
-1. So if we have the values, we cannot go -1 because we don't know what the index is. So to make that coming back to a index, or you can say decreasing an index, we need the index instead of the values.
So this will be 0, and this will be just length of array minus 1.
Yeah.
Now these are the values which we are using, and we can iterate or increase or decrease those values according to the question. Now
Yes.
what we do, we'll make a while loop, and in that while loop we have to do something like we have to make a check if our values are equivalent to the sum, target sum. If array of I plus, we have to use the brackets here, array of x plus array of r is equals to target sum.
Yep.
Then what we have to do, we have to iterate or increase.
Or we can return it now. We can just return. We just need to, no. Before returning, we have to increase the indexes.
Mm,
But one more thing is there. If we start returning here, we will not be able to check further numbers which can also have the same target sum.
okay.
Since we need all the possible numbers now, and if we return at this point, we may not be able to find all the possible target sums because we have returned at the first match. We said like, okay, we got our two numbers, we will return from here. So we may miss some of the numbers which may come after this.
Okay. So what do you think we have to do here? Like, what's the best approach?
um do you think like adding an like creating a local list and sending it back will be a good idea?
Creating a local list and sending it back.
Like and we
Like
can
we
create.
can do,
Yeah,
Mhm.
tell me.
we can do that, but I'm not sure if it is optimized solution or not.
Hmm. Okay. Another way, what I'm thinking is we can do one thing. At line number 6, we can pass the result out as an argument, and we can start amending these fields inside it.
That would be a better approach.
Yeah.
We can pass a list here and we can just append those values which is
Inside,
equivalent.
yeah,
And
right.
we will append what we have to append all the numbers.
Yep.
Okay, but how we solve this that all the triplets themselves should be ordered in ascending order. So in that appended list, the number of I, L, and R should be in the ascending order.
Yeah, because we have already sorted the list. List is already in the sorted manner. I, basically not the I but your L. So you may need
L
to
and R are
update.
sorted.
Yeah. And I is something that is coming from. Okay, that is coming from the above for loop.
So for sure it would be L comma R, but we are not sure where we put the
Put
I.
the I. Yeah, right. That's a catch. Hmm. Okay, let's do one thing. Let's these to some point. Let it not be sorted. We will optimize it later on.
Okay. So if I put L comma I comma R, so for the first case, L and I are equivalent. For the second case, my I is already increased by the next position,
Hmm.
and for the third case, it is already increased. Like it is increasing on every recursion cycle. So if I use L comma I comma R, I start from L and it end at the position of R. So it will always come in between of those values.
I think we should do some optimization for that. We can do what we can do is, since we are using this while loop for starting and the last, so we may get some of the duplicate values here as well, because for every index we are checking from beginning to the last,
Yes.
so we may get some of the duplicates value. So let's do one thing. Instead of putting the value of L at 0, what we can do is make the starting point as the current index, that is I plus 1. So we will never go like you can say before this index. So we already know
Okay. So
whatever the values we have already checked, it already
mm,
with us, and we will not
that
encounter them once again.
it reduce the search.
Yeah,
We
and it
don't have
will,
to search on the
yeah,
previous value.
and we, since we already have it, we don't want them anymore.
Okay.
And now I
So
think these all will be in the sorted manner because we are not going beyond I. So our this I is the maximum, then I, this L will anyway plus 1, so it will be more than I's values, and R is anyway the last one, so it's bigger always.
the sort would be I and R.
Yeah, then now it will be I comma L and R, and not these indexes but the values, so we may need to put as array of I
Oh,
and all these things.
yes, yes, yes. We have to use this something like this.
Yeah, the same, but replace the plus with commas.
Yeah, with commas.
Yeah.
We have to use this with commas instead of plus. Now it will append for the first two case, but if this two will appended, otherwise what we have to do,
And we may
we
need to
have
increase the index as well, no? Because now it's appended, but anyway it's a while loop, so we need to increase the index.
if
So
this is true, then we'll move that I L to by one
yeah, L by
and
1.
R reduce by one.
Or
So
we
L will
should not need to remove that R to minus 1, because maybe that number can be used with any other number as well. Is it correct? I think so.
yeah, your point is correct. Let us repeat the question. Repeat the question. If they have mentioned that every other two number can be used separately with the third number,
Yeah,
then we don't have to reduce the R.
yeah.
So in this question, they haven't mentioned that these three values are unique. So we have to like until unless they have mentioned that we have to consider everything as like we have to consider duplicate value as well. We have to consider unique value only.
So unique will be the triplets, but not the values. You get my point?
Mm. So like even if we do that, we don't have to. We will have to reduce the R because if we don't reduce the R,
Mm-hmm.
then left position, then we will get all the values.
But since we are increasing L, so that might be a case like those two consecutive numbers are they are have same values. Like two consecutive indexes of the array have same values. So if you reduce the R, you may miss one of these combinations which was occurring once again because of those same values.
Okay.
Or we can do one thing, not decrease the R. We'll see if something went wrong, then we anyway we need to optimize it, so we'll see.
So for true case, we have written this. Now let's make for the false case.
Yeah, if it is greater or less than.
Then we just have to iterate. We don't have to like pass something.
We just need to change the indexes, nothing else.
Yeah, we just have to like iterate our L and R position.
So we may need to
We
pass
don't.
these LNR as the while loop condition, or we missed it somehow. Like you intentionally not put it there, or like you missed it.
In the inside the while loop.
Yeah, like
So
do you
I
know?
haven't added the end condition yet.
Mm-hmm.
We were just thinking that what we have to do inside the while, then we'll think where it will end, and we'll update end accordingly.
Oh, okay. Yeah, that makes
But we
sense.
can do it right. We can do it right now. That's not an issue. So what will the end condition of this? End condition will be when we have reached the L position, left position at the end of the array.
Mm-hmm. So we are just
Or I
using
can,
L and R as the indexes to like for all these computations.
so when L is greater than length of array,
No, no, it should be less than that because if it is greater, anyway, it will not go beyond this.
we are increasing the L, right? So if we are increasing the L, we have to check from the right side value.
Mm-hmm.
So it should be less than length of
Yeah,
array, right?
yeah.
So we have to add another check as well
I don't think so.
for
Like this
right.
is fine because right is
This is
anyway at the maximum of it. So, but yeah, you're thinking that you're saying right now because we are anyway when there is a this sum of these three values are greater than target sum, then we will decrease this last value that is R. So if we are decreasing, we need to put a check like beyond this. If it is decreasing, then we should be out of the scope.
so R should be greater than length of. Sorry,
L, I think
should
it
be.
should be L.
So we are updating L on every iteration.
Mm-hmm.
So if R is greater than L,
It should be less than
R
L,
is
not greater than, because R is at the maximum position. No?
okay. So R is the maximum position, which means Rth value is fifth or sixth, and L is one.
Yeah.
So how can you like saying that R should be less than one? 5 should be less than 1. If it is
Right.
happen, we won't enter the loop.
Right. R should be greater than L.
According to me, it should be greater than.
And in that case, we can remove the first condition because anyway, the second condition will handle all these cases.
Okay.
Because anyway, if we are decreasing R, then
Mm-hmm.
it will not go beyond length plus length of array because R is already at its maximum. So if we are decreasing, that means it's at its
Well,
maximum.
let's put it here for now.
Okay,
We'll remove it. There's no
let's do it.
loss of adding extra condition
Mm-hmm.
which can make our code safe. So if those values are not greater than target sum, then we have to use this brackets here. We can use NF. Then what we have to do, we just have to
Since it's greater, the sum of these three numbers are greater, we need to subtract, like we need to decrease the index from the left side. Sorry, the right side.
the right side.
Yeah.
Sum is greater, then we have to reduce the right side because the array is sorted.
Yeah, we know the very last of the right side number is a biggest one.
And if it is less than target sum, we have to increase the length.
Yeah.
And if we are okay,
So at the last, now we have everything in our output
we don't have to return anything because we are already appending.
and everything in the output. And then
So
we may not need to put that at the line number 6, that out dot append, because it's already in the out.
yes, we can directly pass this.
Yep. I think this should work fine, hopefully.
Let me print here. So this is a medium level question. Difficulty is medium level question,
Yeah.
which you are going to solve.
Yo.
Whoa,
Great, man.
we have passed.
Yes.
I've never expected that we will solve this question in a first go. Like we will
Yeah.
pass all the test cases in a first go.
And even though it was a medium level question, that it's not that easy as well.
Oh, it's not that easy. Medium level questions are quite a bit difficult as
Yeah.
compared to easy one. And in the easy one itself, we have faced some difficult problems.
But we have made the CD for you. Now you
So
can solve
according,
it like easy one.
so, so it's just a simple like approach which you can like make it byte by byte.
Yeah.
And if I give you the complexity of this question, it would be and what would the complexity be? Because we are using one for loop here and another loop here. It would be,
It's just n square.
yeah, according to me, it should be n square. Let's check what is the
What they are
optimal
optimal. It's n square.
optimal is n square. Yes, time complexity.
Because at line number 4, it's array dot sort. This that has the complexity of n log n.
N log n.
So
Yes,
n square is bigger than that. So
yes. So the complexity here is n log n, and it runs like n square is always greater than n log n.
yeah.
If our complexity would be n, then of the below function, and this for loop, then we have to use n log n instead of n square.
Yeah. Because we use the worst type
First,
complexity.
let me submit the code.
You may X you want if you can remove that line as well. That
Yeah, we don't have to
print anything.
print
It looks like- Let's try if we can remove that extra condition that I was talking about, and if it runs fine, like runs.
So if we just check if our value, yeah,
Okay. Because so I was thinking about it. It might be or might not. Cool. Yeah.
Yeah,
Nice
that's
question.
all for this question. Nice question. It was not that difficult,
Yeah,
and we have took some time. But
it's all about brainstorming, so it was good.
yes,
Okay,
nice. Okay, thank you.
thank you.
We
See
will
you
come
guys
back.
later. Yeah.
We will come back with some another problem.